So, here's a wild thought. Is writing a simple sentence the new way to write code? Today, we are diving deep into prompt engineering and asking a question that just might be reshaping the entire future of how we build software.
I mean, it sounds almost too simple, right? Just talking to a computer? But what if that conversation is every bit as structured, as intentional as writing a perfect line of code? Let's get into what prompt engineering actually is.
You see, this isn't just about having a casual chat. It's a real discipline. It's all about crafting these super precise prompts to translate what we want into something that AI can actually do. You're basically the diplomat, the translator between the messy world of human language and the logical world of the machine. And here's what's so fascinating. This talking to an AI, it has a surprising amount of structure, a lot like traditional programming. This isn't random guesswork, it's engineered.
A really great prompt, it turns out, is built on 4 pillars. You assign a role, you define a task, you provide context, and you set constraints. Now, if that sounds a little familiar, it should. These are basically the variables, the functions, and the parameters you'd find in traditional code. You're giving the AI a structured set of instructions to get a predictable, high-quality result.
In fact, this whole structured approach has gotten so effective that an entire field of scientific research has popped up, and it's dedicated to automating the hunt for the perfect prompt.
Yep, it's a real thing. It's called Automatic Prompt Optimization, or APO. The whole idea is to use algorithms to discover the most effective prompts for any given task, taking all the guesswork out of it and turning it into a repeatable science.
And the process is really systematic. You can almost think of it like natural selection for prompts. You start with a few initial seed prompts, you generate a bunch of new versions, test how well they work, and only the best ones survive to the next round. It's a full-on evolutionary cycle for sentences.
Okay, so let's take a look at this. What you're seeing here is the entire APO system laid out. This really shows how we're moving from prompt writing as kind of this creative art form to a repeatable science. This loop, generate, evaluate, filter, repeat, that's how we get to a highly optimized prompt.
And this isn't just a single method either. You've got multiple competing techniques, APE, Prodigy, OPRO, and each one has its own unique way of generating and evaluating prompts. It's a rich, developing field of computer science. But as we get better at optimizing prompts for performance, we also have to get way better at securing them. Because with all this power comes a really serious risk.
And that brings us to a major security threat. See, when you give a model incredibly flexible inputs, you're also opening up a massive attack surface. Welcome to the dark side of prompts, prompt injection. And you don't have to take my word for it. The Open Web Application Security Project, OWASP, they put it bluntly. These vulnerabilities can cause an AI to completely violate its own rules, generate harmful stuff, give up sensitive data, or even influence critical decisions. The stakes here are incredibly high.
Now, there are 2 main types. You've got direct injection, which is when an attacker themselves intentionally crafts a malicious prompt. But then there's indirect injection, and honestly, this one is even scarier. That's when the AI is just doing its job, processing a web page or a file, and it accidentally ingests a hidden malicious prompt that was buried inside.
And the ways attackers do this are getting so creative, it's kind of mind-blowing. They can hide instructions inside of images. They can split a malicious prompt across several different inputs so it flies under the radar. They can even just add a string of what looks like gibberish to the end of a prompt that magically tricks the AI into ignoring all of its safety protocols. So, okay, now that we've seen both the deep science and the serious security risks, let's circle all the way back to our original question. How does prompt engineering really stack up against good old-fashioned programming?
Well, the absolute crucial difference really boils down to this. Programming is built on a formal, rigid syntax. The same input will always give you the exact same output. It's deterministic. Prompt engineering? It's the total opposite. It's flexible, it's free-form, and it's probabilistic. The same prompt can give you slightly different results each time because it's always open to a little bit of interpretation.
So after weighing the structure, the science, and the very real risks, what's the verdict? Is prompt engineering actually the future of programming? You know, the most likely answer is that it's not a replacement, but it is an incredibly powerful partner. The future is probably a blend of both. Prompt engineering is going to be absolutely amazing for creativity, for brainstorming, for getting prototypes up and running fast. But for those critical, high-stakes systems that demand perfect reliability, the precision of traditional programming is still going to be king.
Which really leaves us with one final thought to chew on. Will the next generation of great innovators write their world-changing ideas in Python, or will they write them in plain simple English? The thing is, the answer isn't one or the other. The future belongs to those who can master both languages.